I suppose.
Hello, YouTubers. We're starting a new session, and I got Paul from minute zero, starting to talk to us. And Paul, how are you doing today? How is the United Kingdom?
Yeah, not too bad. Here
Also,
in the news,
also,
some heavy news at the moment, isn't there? For the
yeah. The news is breaking my heart, man. I can't believe what's going on. It's just, I just hope people are safe. That's all.
heart
Uh,
goes out to them. I don't know why people fight these days over such things as borders. It just doesn't matter.
I thought we moved off of this whole, my rocket is bigger than your rocket kind of thing.
Yeah. Maybe we're idealists though. As engineers, we're more scientists. We don't care about things like politics. We care about progression and you know.
Yep, evolution. Politics used to mean just taking care of people, sweet and simple. Now it turned into optics. How can I make people believe what I'm saying to them, even though it's not true? It's so sad. Anyway, we have Joe here. Hi, Joe, also known as Shooty McStappy, my favorite alias in the whole world. So Paul, Joe and I were having a side discussion a little bit, and Joe had some questions and some he wanted us to kind of clarify what we really mean by the lake house and what does that really imply in terms of implementation. And his concern was, he said, I don't want to derail the conversation. I just want to see if the group want to get on the same page on this particular topic, and then we can jump straight into tokenization. I mean, today we have to write some code, of course, because tokenization, we figured it out. Let's go implement a tokenization service. That's not a problem. But would you entertain that, Paul? You want to talk a little bit about the lake house?
Yeah, funnily enough, me and Sam had very kind of similar questions, and I think I hinted on it last week that I've got kind of my apprehensions about kind of what this lake house actually is and what it means at this point.
Yes.
What I think Sam would like to do, and I'm of kind of a very similar opinion at this point,
Hmm.
is effectively just kind of plot out the landscape in kind of interface form so we can sort of write all the interfaces but not populate any code behind them. And then what we can do is we can start writing tests against those interfaces. So then when we do implement them, we know what we're implementing. And
Hmm.
I think that, speak of the devil, here he is.
Hey, Sam.
Uh, so I was just saying that, following our last session, we were talking about kind of like, well, I think the question that was raised is what does this house look like, right? We know we're going to have walls and stuff, but hey, let's just kind of establish some kind of framework, put some beams in, put some foundations down, and then we can start to say, hey, off of that, we're not too worried about like, the color of the paint on the walls or, what carpets we're having yet. We just want to get that kind of rough framework in place so we can say, this is kind of the rough model that we're going for. Does that
So the,
sound?
so the whole map is a little bit of the whole map is interesting. Like, having unknowns is part of the fun, right? We do know that we need some tokenization. We do know we need to turn these tokens into hierarchy in terms of O nodes. We know that some services will use these O nodes to kind of turn them into expressions and statements. So far, we're on the same page on this, Paul, right? You agree on that part? No
Yeah.
problem there. What about you?
Yes.
What about you, Sam? You're good on that? Joe, are you also good on this? Okay.
Yes.
So we know that for sure. And let me just to kind of share my screen here just to make sure, I really want you guys to kind of when we're thinking about these problems, again, don't worry too much about making mistakes. I want us to make mistakes and I want that to be public so people understand the software process is an iterative process. So just from a conceptual standpoint, back to what we were talking about, we know that we need a tokenization process. And after that, we need, what did we call it, Paul? Query builder? What did we call the O node service? We called it something. Let me call it processing
I
service
think we were
for
talking
now.
about model building, weren't we? So we were going to
Right.
do tokenization, then model building, then
Hmm.
processing, whatever that involved.
Okay, model builder service. right? And then we talked a little bit about the next stage. I want us to agree on this because this is our high level, right? So, and then you have the processing service, and this processing service will leverage whichever other things, components, services, other functionality it has to determine how it's going to turn this model builder service into a query that fits whatever business logic. That query can be an expression, it can be just a simple, it could be a link expression, it could be a string, it could be anything we want it to be. So just so people understand, this would be something that handles select, and this would be someone that handles filter, and this would be someone that handles, I don't know, order by and compute and all of these different, or expand and all of these different statements. What that basically means is that at any point in time, someone could come here and say, I want something else like this in here that will produce, instead of expressions, it will produce raw, queries. It'll produce whatever else that we want it to produce from the other side. These guys are not going to change at the beginning. We will allow people, this is where the Lakehouse comes to be, and we go and say, no, I want my own tokenization processing to take place. Now,
Not change it doesn't mean customer can. It doesn't mean a customer cannot extend it, right?
no, they can, they can even
Yeah.
throw it away if they want to,
Yeah.
but they are less, I'm sorry, I misspoke. They're less likely to change than these ones. Why is that? Because these ones, some people will take this like, okay, remember, there are three goals of this project: transcendence, technology agnostic, right, and pluggability. And I'll talk to you about that in a second. But what we're really trying to do is that if I have a gatekeeper and I have a microservice, I want that gatekeeper to take the OData query and transcend that query to a bunch of other microservices. So your translation here is not always going to be an expression. It could be anything else that you want to do to turn it back into a query and shoot it from the other side. In a situation, your controller will take that query, your OData Neo will turn it into link expression, and then at the very end, at the integration level, it will pick up that link expression and turn it back into a query and shoot it back to other services. There's also the concept that we talked about a while back, which is, the fanning out, like the aggregation. We'll send a bunch of queries to different services, and then we'll come back and aggregate all of those and shoot it back to the customer. The customer is none the wiser when it comes to knowing, where this data come from. It could be coming from multiple data sources. That's literally how you're gonna evolve OData from 13-year-old technology into bringing it to the day and age we're in. Do we disagree on any of that? Do we have any issue with any of that?
No,
Okay.
it looks good.
Okay.
Well, I had some questions about that.
Go ahead. Go ahead.
Like, when I sort of think about how I'm going to use what we're producing here, I always give the example of constructing a new OData query object from the string, because it's the simplest way to kind of think about the problem for me, which is then sort of a thing that I can kind of consume in its own right. The way that you explain it, to me, feels like you're trying to build something very similar to the existing pipeline, where you've got kind of an OData question and you want to run it down through a kind of servicing stack, essentially, that results in a question on a database and then some result.
Well, that's where the Lakehouse. Go ahead.
Yeah. So what I'm thinking is that there's multiple stages to this, right? So one part of it is the separation of OData and the reuse of OData as a protocol. And another part then is encapsulating that in some kind of application stack. So I think we should be, at the moment, focusing on the things that matter about processing and parsing, essentially, queries into some other form, like an expression tree, and making that a reusable piece of functionality.
Like right now, at this moment?
Yeah, the design for just that is what.
Oh, the design for that. Yeah, that's okay. I'm okay with that. Now, let me just tell you something. Why did I propose the Lakehouse pattern, right? just for the people watching us, this is not a known pattern. I literally pulled that out of my butt. So just hear me out and I'll tell you why we need something like that. So this Lakehouse pattern will allow me to go and say, you have a bunch of services sitting in here and they don't know about each other, but they know about the events that they're interested in. So they don't even know the contract, Paul. Like these services, they don't even care about the contract. They say, if you have that event, I will map whatever raw, payload you have in your event to whatever matters to me. Okay? But
Right. So
that,
thinking about taking that a step further, because we've had this discussion since we started the project, essentially. So what I would say is, okay, let's define an interface that represents the Lakehouse, and let's define an interface that represents, say, a message that can be patched through that Lakehouse, and then define what a handler looks like. Because what we're essentially talking about here, as I understand it, is something that's much like a service bus implementation.
it is. It's very,
Well, okay,
the
if
only
that's what we've
difference,
got, why not
don't,
use, say, N service bus or
right.
RabbitMQ or something like that? Yeah.
So the difference between this and that is that, first of all, it's built in. You don't have to actually go get a resource in Azure or in a cloud system, whatever the case may be, number one. Number two, service bus is fire and forget. This guy implements a new pattern called file and observe. So when I am sending you a message in here, I am watching it. This guy is still watching this message to wait for it when it's prepared, and then it receives it back, because it's not always fire and forget scenario. It's going to be a scenario where you want to go. This is the innovative part of this. You're going and saying, I'm going to put a message here, but while people are working on it, I'm still observing this message. I don't know who's working on it, but I know that I want my message back whenever it's ready.
Okay, I'd like to see, and I think Sam would as well, I'd like to see what that means in terms of functionality. So let's think about it in real world examples. If I had a block of code that was a consumer of this, what would it look like?
Right. So let's say, for instance, this is your API controller. This is your controller in here, right? And your controller, from a high level perspective, your controller is talking to a service, and your service is talking to a broker. And your broker is going and talking to some database, whatever the case may be, right? Here comes OData Neo. OData Neo will be living in this tiny space in here within the controller itself. This is OData Neo, just like how you use OData today. The only difference is inside that little box, the following will happen. Inside that little box, you have your OData Neo sitting here. So this is the system within the system, right? So let me encapsulate all of this under one box. That's your DLL library at a time, or DLLs, because you could be pulling in more services to attach to that Lakehouse. And then what's happening really is that this guy is your client. It's the exposed capability from your OData Neo library. This is you basically going and saying in code, let me pull a file format here. Here's your file. This guy would be something like this. It's going here and saying, apply query async, and you're passing in your OData query in here. So that's this guy. Its only job is that it's an exposure component that takes in a raw OData query and produce something else. What is this something else? I'll come back to that in a second. Could be an iQueryable, could be an expression, could be a string. We'll talk about that. Okay? Now what's happening here? The customer that's talking to your controller, the client, is sending you an OData query through your controller. Your controller is handing this over to this guy, because that's all it sees. It's just a library, a DLL, that says apply query async. All right, is the image too small for you guys, or can you actually see what I'm doing?
Yeah, it's
You're
okay.
good? Okay.
You're good.
So the query is coming in, right? What is this guy gonna do? Now hear me out. You can't actually fire and forget in this scenario, because the controller is waiting on you to actually do something. So you can communicate that to downstream services in tier architecture classic pattern. So what this client is going to do, it's going to go here and going to go and say, hey, I want to apply this OData query with event X. Let's say event query, query select, whatever the event may be. Some services in here are subscribed and interested in that event. This guy didn't let go of that thread yet. This guy is saying, I'm watching this guy. I'm waiting for this guy to go into a state that says it's ready and completed so I can shoot back and say, okay, process completed, done. This will happen in like a split second, literally 20 milliseconds, boom, here's your response. But what's actually happening, if we slow down time a little bit, what's actually happening is that you have this tokenization service in here that will go and say, oh, wait a second, I'm actually interested in this message. This message here is my interest as an event, and I would like to access this message and do some stuff to it. So far, so good, right? So the tokenization service will go do some work and then flip the event in real time and say, this message now is a responsibility of whoever cares about the next stage of this thing. Well, I'm done with this. I'm going to go and pass it forward a little bit to our, let's say, model builder service or processing service. Same thing. And now we have your processing service. Same thing. And now your processing service is working with whatever brokers it needs to turn that into an external model, like a link expression or a query or whatever the case may be. So this processing service in here, in a way, has its own brokers sitting down here. And it's basically saying, hey, here is this query. I want to leverage your capability to turn this into an expression. And once that's done, it goes and says, okay, message is done, completed, send that message back to this client and shoot it out to the client as whatever that last consumer that called it off have decided that this message work is done and we don't have no more interest in this message no longer. Why is that important? None of these guys know about each other. None of them know about each other. All that they know about is that there is an event that they're interested in, and this event gauges their interest into doing one particular task. Now, who is the determiner that this message is ready to be, kind of returned through the client? Who determines that? The client themselves. The client says, whenever this message reaches this particular event or particular state, I would like to have it back so I can give it back to whoever client is consuming this endpoint and whoever is consuming this process, and I can shoot it downstream. That basically means at this point here, OData Neo will get a string from the controller, that's the query, and process it and turn it into an expression that will be consumed through your in-tier layer. Now here comes the fun part. You can take that exact same OData Neo and put it right here and say, hey, I want to take that expression and turn it back into a string so I can shoot it back to downstream APIs. That's the fanning out and aggregation. Is this too complicated? Is this over engineered?
I think there's some so there's some defined stages that would exist in this Lakehouse area. Those stages could be structured in a way that you could want any one thing in that to return the response in that complete stage, or you want to wait until all of them do it. That's an aggregation point. So I think there, as far as Lakehouse is concerned, there's a whole separate project just there defining that.
This is why I kept saying the Lakehouse is just a transportation layer. Don't even talk about it yet, because we can actually go to production. We can literally go to production and release OData Neo Preview 0.1 without having to implement the Lakehouse yet.
It should be able to be used with the Lakehouse or standard, let's say, ASP.NET Core pipeline.
Yes, sir.
Pipeline.
Amen to that, I believe. Exactly what you just said.
Okay.
Yeah, it looks like ASP.NET Core pipeline or filter pipeline, and any service under the Lakehouse looks like the middleware. It's a plug-in to the pipeline. Does the order matter?
I love you, Sam. Yes, order sometimes matters.
Yeah.
Sometimes. And we want to have the ability. This is why, like Joe said, Joe now gets it. That lake house is its own kind of management event, kind of substrate
Mm.
that lets you determine which components should execute first, whether you care about the order, and when do you call it done.
Some clients can even inject themselves at the processing layer and then continue on at that point.
That's the point. The point is that someone could go and say, hey, by the way, I can commission and decommission. I can go here as a client and say, hey, we don't like the performance of some of these services. We're going to inject our own, and we're just going to listen to that event.
Mm.
And none of these guys will be impacted. This is taking dependency injection to the next level. Like
Mm.
literally in dependency injection, you basically define a contract and you say whoever concrete class wants to implement that. But at the end of the day, you still have to determine which concrete class you want to leverage and which methods that concrete class needs to implement. In this case here, you're only subscribing to an event. You don't even know who posted that event. Anybody
Yeah.
could say, you could go to NuGet.org and say OData Neo dot processing XO, right? This is my own library, and I can download that and inject it right into the product that we're building here. It would be like a shell where anybody can post their own libraries, and it can literally go right into that Lakehouse and say, okay, I'm ready to start processing some of these events. I'm turning OData Neo into a marketplace for components that you can plug in. Remember about 5 or 6 sessions ago, I was talking about Project Christine. Do you guys remember when I was talking about that? Project Christine, it's basically a company. Google tried to do the same thing as well in terms of hardware. Let me just show you this real quick. So, here's Project Christine, and what these people said is that we want to make assembling PCs the easiest thing in the world. So what did they do? They built the substrate. Do you see that little, hold on. Do you see this little substrate? Do you see that little tower in here? That guy is agnostic. That's your lake house right here. And you
Mm.
literally plug in whatever components you care about.
Mm.
You want more graphics, you want more hardware, you want more, it doesn't matter, whatever you want, and then they all kind of talk to each other, and now you have a PC. How crazy is that?
It's a consumer blade server.
Yeah, pretty.
It looks good
It's
to
got a
me.
backplane. That's the only thing that makes it special.
Yep, absolutely sure.
And the lake house looks like the pipeline. The lake house defines the interface. Each one is the interface, and the lake house can choose an event can choose the message from event 1 to event 2 to event 3, blah blah blah.
Yep.
But the order is built
Yep.
within the lake house. Anyone can subscribe the event.
Yep.
If the lake house monitors the interface, if it finds events subscribed, will call this service
Yep.
call the
Yep.
public middleware. Yeah.
Yep. And I think I did something. I really did a really nasty, like quick and dirty POC for Lake House. I just don't know where I put it. Hold on. Swear to God, man, I did that a second ago.
It's a choreographed pipeline with mediated steps.
Sure, I would take that. I like it.
Yeah, like the whatever this thing's doing, the steps that it takes to do that is mandated by whatever's creating the lake house, and then all it does is just route from the request from one stage to whatever component, one or many of them, and then gets to the response, and then whoever's in charge of defining the rules for the next stage gets to decide if they move on or not.
Exactly. And you get to control, like, again, this is abstraction on steroid, right? You're basically taking your services and you're saying, okay, I'm done with this dependency injection as we know it. I'm going to only do a dependency injection through the lake house. And everything that's coming through the Lakehouse, that's my contract. I'm even canceling the models. Remember last session I was saying, oh, contracts is the last, coupling that we have. I'm even getting rid of that. I'm thinking about actually making it just a dynamic component. You can serialize it and deserialize it to whatever you want. And it's all built into the Lakehouse itself. So you just need to pass in the model that you care about and turn it, whatever event payload that's coming back to you, into whatever you need. It's its own project. This is why I don't even talk about, because it can be used even outside of OData. Like this very same project, it can basically be used into building your ASP.NET Core applications. But that's like the standard 3.0. I don't even have time for that yet. So
You can manage interactions between microservices over a long stage of events.
that's event sourcing. That's modern architecture. Right? The only difference where the current architecture fails is that it doesn't have a concept of fire and observe. This is why I'm calling it a lake house. You know what Sandra Bullock did? She went and put the message and waited in front of the box. Fire and observe. She didn't put the message in the box and walked out.
I'm a little confused here. How does this differ?
You gotta watch the movie.
You're gonna have to. Didn't I tell you guys you need to watch the movie? You guys are disappointing me. It's kind of mandatory. Lake House, last scene. Come on, man. What do I do here to make you guys, huh? Hold on. Let me just find the part where she just put the message. There. Watch this shit. Watch this shit. She put the message and she waited. She fired and observed. That's what I care about. Come on, put the damn message. There it is. That's the Lake House.
The mailbox?
And they stole it from a Korean movie anyway. It's not the real, that was a Korean movie. But anyway, okay, back to Paul. What's confusing, Paul?
Well, isn't this a standard pub-sub model? So you have publishers and subscribers. So you can publish an event or you can subscribe to an event. This is standard service bus type stuff, right?
Yeah, but the publishers of the event, they don't wait after they publish, though.
Well, they can do, because you can publish an event and you can say, okay, I want to subscribe to the result of that event.
Ah, that's the lake house.
Right, but you can do that with an existing service bus implementation is what I'm getting at.
You can?
Yeah.
Can you show me?
So one example would be you can make this kind of behavior with BizTalk, but you can also do it with things like end service bus, for example, which is
wait a second. Did you just say BizTalk?
Yeah.
Okay, leave the session. Come here. I don't think
I know BizTalk isn't sort of, inline or sort of, within your application stack. But what I'm saying is like that does it, essentially that does service bus as a server, right? Whereas what we're looking for here is a sort of component that we can embed inside our applications. And potentially, if I've understood this correctly, you might have many lake houses that can talk to each other and they form a substrate. And that is essentially what Microsoft invented things like Azure Fabric for, right? It's the same kind of thing. You have some kind of, I guess the most obvious implementation would be SignalR when you have backplanes. So you can talk to a hub and your backplane ensures that communication happens potentially across multiple applications.
Yeah, but you don't have the control over the event. That's what these patterns are lacking.
But the backplane does. And you're talking about the Lakehouse being the equivalent thing to the backplane.
Sort of, yes. I want to be able to go and say, here is a message, but I'm going to watch this message. Even though I just published it. You get it. You get the idea.
Yeah, I think I get the idea. I'm just struggling to determine what the difference is between existing models that do very similar things.
I also don't know if there is anything today that you can just plug and play. Like, we want to control priority. We want to control subscribers. You want to get all that kind of control in your substrate, in your lakehouse. And you want to be able to go and say, I want to determine for the observer. I still want to see how you would, put a message on the event bus or service bus and still observe it. I'd be very interested to see that because your consumer doesn't publish back. So how do you know? It picks up the message and it leaves. It drops it. It's over. So even if you're observing that, man, I've been using Service Bus now for almost 5 or 6 years. I'd love to see that implementation that you just talked about, unless you're building two queues and you're putting a message on the queue, but you're also subscribed to the second queue where the customer is going to push messages through that queue.
That's literally it. Yeah.
If that's what you're talking about, that's different. You're basically doing you're not
you send
really
a message, you get a different one back.
right.
What you're talking about is you send a message, you get your one back, but it's been mutated.
Yes.
So are we talking about, for example, I can push
but
in
let me
an
tell
object
you why. But let
and
me
then have the queue of stuff do something with that object, and then I receive that object back, and then I can say, great, now that it's in the form I want, I can use it.
Mm-hmm. And why is that important? Because even if you do that two queues scenarios, you're still firing and forgetting. So the customer that's waiting on the other side is gonna be told we're done. You're gonna tell them accepted because you didn't get any feedback on that message that you fired and got consumed. You still have to wait for a new message to come in, and you already lost your session. You already lost your client.
Well, you can subscribe to messages that match messages you've previously sent, right? Depends on how smart your service bus implementation is.
See, now we're getting into customizations, right?
Yeah.
This is why I want something outside of the box that says, fire a message, wait for it, tell your client, wait, they're still working on it. When it's ready, give it back to them. It's fire and observe. It doesn't exist on the internet.
So I'd like to put this to the test, right? So let's write a block of code that would potentially be a consumer for some possible use of this. It doesn't matter what that use is, right?
I swear to God, man, I had one. Okay, just keep going, and I'm listening to you. Keep going.
And let's say, okay, we're going to write a block of code that represents.
So Lakehouse.
No. I've got an OData query, okay, and I want to do something with that query to get something that I can use. So I don't know. I've got some IEnumerable T, right? And I've got a query. So what am I doing? I'm passing my OData string and my IEnumerable T in, and presumably I'm getting back some kind of result that I can serialize as an OData response, something like that.
Yeah, absolutely.
So that for me would represent an absolute bare bones of the functionality that we're aiming to achieve. That would give us essentially the beginnings of a public API that we could say, okay, from this start point now, we need to start working our way down the architectural stack, which obviously, as you've already pointed out, begins with the tokenization side of it. But at least then we're starting from some kind of business object that's going to give some kind of result that we care about, right? And then over time, we can start to look at, okay, what does that mean in terms of testing, for example? So if the object in question that we're feeding this into, I know we've talked about this before, where we had, like, say, an OData query object. You define a new instance of that, and that could be the container for this Lakehouse thing that you pass your string into by calling a method. You pass your IEnumerable in, and it gives you back your IEnumerable of some other type potentially back, depending on what's happened to it, right? You get an object back. So it might be worth us starting with something like that and say, hey, let's just define a test that will execute that. And that test could start by doing something really simple, by just, like the tokenization side of it, right? So you were talking about having different pieces of the chain that you could potentially be interested in. So rather than
later on
back, so rather than wanting back, say, my IEnumerable, the object response that I could want back initially could be my token array. Then we can extend that further, and I can say, actually, what I want back is an O node that represents what I just gave you. Now, next, what I want back is my expression tree.
Oh, you can even define the type of data you want back in your event. Oh, I love that. I love that. So you're not just sending a message, you're basically, I want my message to come back. It's like going to Starbucks and you're saying, hey, it's like Starbucks. You're stopping in front of the, do you guys have Starbucks in Britain? You don't.
Yeah, of course we do. Starbucks is everywhere, right?
So you stop in front of the, at the box and you say, hey, I want chai latte.
Yeah.
You don't know who's really
give me
taking.
a thing of type T. Yeah.
Yes, and you don't know who's in the back is working on it. You have no idea. The only thing that you know is that you sent a message and you observed and waited until the latte came back.
Yeah. So you pass in a string.
You
give
have
me
to
back
make sure
an innumerable of some T.
There's a human being for you.
You have to make the choice, right? What's interesting though is that I know at some point in time you wouldn't even have this nice barista that comes out, and tells you here's your chai latte. At some point in time, this is gonna be automated. Like you're gonna just put in the money and someone is working on it, it's just gonna come back from the other side because you already paid. The whole point why they have people still standing there is because you still need to pay and you maybe need to ask questions, but it's inevitably going to be automated. Whatever Starbucks is doing, that's the Lakehouse pattern. Because you're not making your order and driving away. You're making your order and waiting. You're firing and observing. And when the request comes back, when the whatever, anyway, okay, 30 minutes in, okay, let me just focus on this. This is a transportation layer. Something that I'm hacking together to see if we can, push the envelope of innovation a little bit further. We still need to write a tokenization service. Can we start writing a tokenization service? Is that okay? Yep. No?
Well, I think where we started on this was like the overall architecture was kind of the thing that we wanted to get our heads around, right?
Okay. So, and are we in agreement about the? I'm sorry, Sam. Go ahead. Go ahead, Sam. This part here. Are we good with this guy?
Yeah, it's good for me. But can we start from the Lakehouse?
No, because the Lakehouse is a project on its own. It's like a whole transportation layer where you can still go to production with or without it. You can still link all of these together in a classical dependency injection matter and just move on.
So we're responding we're making handlers basically for some contract that we don't care about yet.
We don't care about the Lakehouse is the last step where you go and say, okay, our tokenization service is talking to this model builder service. We need to come up with a better name than that. But if that's what these two are talking to, now I'm gonna have them point up instead of pointing at each other. How this is gonna work?
To define the event. The tokenizer will talk to the event.
Okay, so whatever your tokenization service will be called by, or however it's going to call things, instead of it going and saying this dot model builder service dot serialize, it's going to be this dot lakehouse dot post message. That's the only difference. I wish I can find the freaking code that I wrote for this. It's literally that simple. I will make a YouTube video about the Lakehouse. It's going to be 2.5 hours and good luck. You're going to have to either make the choice either to watch Spider-Man No Way Home or watch the Lakehouse pattern for some crazy guy that's coming up with some ideas that who knows, but maybe it'll work, maybe it doesn't. But
the problem that you've got though, Hassan, is that these services all have to expose, or if you like, be consumers of a contract that the Lakehouse is going to essentially tell us. It's going to say, hey, in order for you to be part of my pattern, here's my interface that you need to implement.
You won't implement an interface, you will inject the Lakehouse interface so you can post messages and observe messages. That's it.
I think the best way to go about it is to assume that each stage that we're designing right now, the output of one can feed into the input of another.
Yes.
If it needs to get more elaborate than that, then you would end up wrapping those and then feeding them to the Lakehouse.
You're basically sandboxing them, and you're saying, okay, whatever the outcome is. So
because you do want these available in a standard mediator pipeline or any other pipeline,
I like
middleware
that
pipeline of ASP.NET, They just need to be able to be used together. They don't care about who's passing the stuff around.
That could work too.
You need like an iMessage handler interface. Otherwise, all of these services are going to depend on your Lakehouse. That's just, that breaks the whole point of it working separately without the Lakehouse, right?
As long as these services can work together, the Lakehouse or the pipeline that you choose can wrap it and use it for itself, pass it to the next one. It just has to get unwrapped before it can be used again.
I'm okay with that. I like that idea, Joe. I didn't even think about that. I thought, okay, let's just have them plug and play into the Lakehouse. But what about the people that want to go and say, I don't even want to subscribe to an event. I just want to use the tokenization service on its own. I don't want anything else.
By doing it this way, you can then adapt any stage of this to any stage of any other process. It just has to get wrapped and then unwrapped again.
Yep. I am totally okay with that. I love that idea. I think that's a great idea.
So as long as they can work by themselves, then they can be plugged into another system. They just have to be designed to work in whatever linear fashion that they need to be called in.
And that would be extreme decoupling. That's what I'm talking about. Let's just see what it looks like. I promise that next time I will try to find this project. It's really interesting, that you can just, push to a common mediator between all your services and brokers, and they talk to each other without knowing about each other. It's much more freeing in a way. Anyway, let me go back to the project. Can we go back to the project and write code? Do you guys want to write code today? Or are you tired? Is it like I mean, we have 20 minutes. Let's see. This is OData Neo. What I'm thinking is that we should probably implement some sort of a tokenization service. And this tokenization service is going to be the one that basically controls. Let me just go here. Let me go here. Let me go here. Okay, let me go back to the master branch real quick. The main branch. Okay, so here we go. Let me just rebuild. Oh, and also we need to upgrade all our stuff to .NET 7. So in case you're wondering, all of you might probably need to bring in Visual Studio Preview 2022 because you won't be able to run it on.
we rely on a preview from Microsoft. Never.
What do you mean? It's.
I've just never had an experience like that that's gone well. Like I've always had to rely on like the current version or the version -1 because if I go new, it's just horribly wrong.
It's just because you're using it wrong, Paul.
Yeah, totally.
You can do it side by side.
It's great when some other developer completely changes everything from underneath you.
The new version of Preview is definitely side by side, so you should be okay.
Yeah, it should work, right? Foundations,
It's work.
tokenization.
There's a joke from me. 2 years ago I used the Visual Studio 2019 preview. I use it again, so I'm waiting to the official use because but now one day I realized I have to use the 2022 preview.
2022, yeah.
So I never use the 2019 official release. I use the 2019 preview all the days.
You have to. You Sam Shu, you have to. You can't actually use a final version of anything.
Don't those preview builds get out of date?
What do you mean? Like
after a while, they stop working on the preview, and you're just on the normal one.
Never. Like these preview versions are your nightly builds. They never stop. It's actually where the engineers are. It's your div branch. Even Sam, I don't know if you guys know this. Sam doesn't publish to NuGet.org out of the box. He has this other branch where he is actually pushing NuGet packages so he can try them out. What's that site that you use, Sam? What's it called?
MyGit.
MyGit.
Yeah.
That's what he actually publishes his nightly builds. Back a long time ago when NuGet actually started. By the way, NuGet.org uses OData. Just wanted to let you know that. A guy that works on that team says we're leveraging OData big time. But one of the back in the old days, people used to actually publish their nightly builds on NuGet.org, and it got really busy. and it got really annoying. So people started finding other routes to do that. Just like how people do Bitbucket, I think, when they try to publish kind of in development iOS apps. Not Bitbucket, there's something else that they use. But anyway, let's build a service. Let's build a new service. Tokenizations. And here is I'm just gonna put, I'm at least gonna put like the foundation. So I got some people reaching out to me, be like, all you do is talk, Hassan. You never get anything done. I was like, oh, okay. Thank you so much, Father. Okay, tokenization service. And then there is this implementation, which is the tokenization service. We may or may not need brokers to kind of abstract away dependencies on .NET stuff, but that's okay. We can look into that in a bit. And then
You already have this in the child branch.
We do?
Yeah. In the branch that we were working on, foundation tokenization.
No, I know, but we need to start moving things slowly in a test-driven fashion, right?
Right. I thought that's what we were doing. We were testing.
You were doing ONode though, right?
What?
ONode.
We didn't get that far.
Oh, we didn't? Hold on.
No.
Let's go back to this branch real quick. Let me put a work in progress here. And let me go back to that other branch. So that would be the foundation filter infra initialization. Let's see. Is that where you at, Paul? The filter service? Oh.
Hang on, let me find it.
What's your branch called, son?
Yeah. It's called foundation hyphen tokenization.
Okay, and I typed foundations. Okay, let's get the latest here. Let's see what we have today.
So we had some tests where we were starting to build out nodes, but I think what we probably want to do is back out of building nodes and move into building token arrays.
That's okay.
And just build a tokenization service that builds token arrays. And then in line with kind of what we were thinking about future patterns and stuff, once we've got a tokenization service that can produce token arrays, we can then build a node service that builds nodes.
What did you do to this project, Paul? It doesn't build. You broke it.
What? You can't blame me.
Yeah, you broke it. Yes, you did. So you didn't push your extension to JSON, right? Nice. Can you push whatever you have?
Oh, the extension methods. Yeah, you told me to move them. So they're in there. They're in the tests.
They're not.
They're in. Yeah, they are. So if you go to, it's either in tests or test logic. There's a to JSON and a to something else.
No, string. There isn't. Here's the maybe it's this guy here. Then why this guy doesn't know about it? Because ONode, the extension on ONode, you removed the extension on ONode, right? You don't have that anymore. Where did you put that?
Yeah, because you said move it into the tests, right? So I did that. So in the test, I've got a toJSON method, line 76.
Yeah, but brother, inside that guy, there's .toJSON again.
There is, yeah. So I broke it.
Well, that'll do it.
That'll do it.
Sam, what are we gonna do with Paul? You know, we're gonna have to make a decision, unanimous decision about Paul. Huh?
Don't worry, I won't feel bad. We've already fired Hassan at least 3 times, so.
We need to keep strikes to see how many times people get fired during the process of this system. Okay, listen, brother. You know, so the tests that we have today, we're gonna have to kind of throw them away because these tests are trying to take a query and turn it into an ONode, and that's not what we're doing anymore, right?
Yeah, I kind of expected that because that's like kind of like the last 2 or 3 sessions. That's how they've gone, isn't it? Is kind of like we're going too far. We need to take a step back and go from string to token arrays. So what I think we should do is start by just scrapping all of the tests and then create one new test.
That's not test driven, Paul.
What do you mean? We scrap the tests and then we write a new test to test the token service, right?
Oh, scrap the test, like throw them away. Yeah, I like that. I thought you were saying I thought you were saying write all the tests.
No. Scrap. Sorry, my English is too English for you.
You don't speak English. You don't speak English. We speak Americanish.
Yeah, I noticed.
All right, let's start this over. Hang tight.
Paul is native English.
Yeah, he's native English guy. Yeah, he's God help us all. I don't know what he's saying. He probably says let me go to the loo when he wants to go to the bathroom or something. Is that what you say, Paul?
Damn straight. That's proper English, that. You tell me I'm English, you weird American.
Oh man, that's funny. Not implementing Sam. Okay, Sam, we let these guys kind of play around with the code for a while. Look at this little guy. Hi, friend. Hold on. Moment of truth. Let's meet that guy. Hi, friend. How are you? What's her name? Joe? Let's give Joe the focus. Let's see.
There we go. This is AJ. Her name's Abigail.
Hi, Abigail.
She's
How are you?
Nap. So.
Joe, she looks like you.
Thanks. Oh, here you go.
Come here.
All right.
I got you.
Okay, let's go back to this guy. So, Sam, okay, we'll let these guys play around for a little bit. Do you want to write some real code with me? Okay. Because, we'll let Paul kind of do his thing and...
Hang on a minute, hang on. The conclusion that we came to last week, don't you start? So, Sam definitely does have a better implementation of what I wrote, which was essentially a start point for tokenization. I had the idea of using like a dictionary where you could specify essentially your list of tokens essentially in a dictionary, and then you would have a dictionary of type string and then an expression that would return a Boolean. So I can share that with you guys if you want, and we can use that as a start point, or we can go down some completely new route using Sam as our kind of guide here. I would probably defer to Sam's experience on this one.
So
given that he's done it before.
So hear me out.
I would like to write the test and then just come up with whatever's the simplest to make it pass.
Exactly, that's what I'm going for. Let's try this out. Fact, public, void should tokenize query. Sam, get ready because you're going to be writing code with me now. We're done with this. Actually, we have only 4 minutes, guys. Gosh, dang it. Hold on. Let me see if I cancel my next meeting.
Are you done yet?
Hang on.
You'll just write the test. You can write your email too, or message, or whatever your communication is.
He's going to copy and paste it from Sam's OData repo.
What communication term here?
That's it. That's exactly what I'm going to do. How did you figure, Paul? Random token.
It works, right? It's going to make you look good.
Create random token. So here's what we're going to do. We're going to need to kind of create so this randomization function can allow you to kind of inject certain things in the middle of the random string that you're trying to generate.
You're going random again. We established that there were a fixed number of actual tokens that you could have.
But you don't. But you don't care about that at this level, though. Like, let me just explain. Like, if you go like this, if I generate this like this, your tokenization service doesn't care.
True, but now you've come up with a fixed case we can build our code against. So
No,
let's write that as our first test.
I understand. What I'm trying to say is that slowly we're going to start adding more and more separators in this random string that we're generating and then see how our tokenization service is going to react to it. In fact, actually, I'm not even going to generate this guy. You know what I'm going to generate? A random token and then extract
See,
the
I
query.
was thinking we could be smarter about this, right? There are a fixed number of characters that are allowed in a URL. Build a string with them all and make sure that they all come out as the tokens that we expect. That's start point number one. That's a fixed string. And you can literally just do, you know, an IEnumerable of char and pass in char codes to get the array of characters, right?
Right. So let me just do this. Because we're really out of time. Let me kind of, I don't know what the fixed number of characters that are allowed in a URL is. It could be, I guess, exclamation.
No, not number of characters. Individual character
No, I
types,
understand.
values.
No, I understand.
Yeah.
Like I was just saying, exclamation point is not an allowed character in a URL, as far as I remember.
Right, yeah. So we need to
Right.
determine what that set is, and for each one of those individual characters, determine what that maps to as a token. If we get that much correct, that's our first basic test.
Sounds good to me. But we're
No
gonna have
randomization, just fixed values. This is what single
still
characters look like.
you still need to generate random values in between those, though.
Well, I think that's the next level on, right? So step one is individual characters. Step two would be to match on things like operands, which are fixed 2-character tokens. And then step three is build random strings that use those things and make sure they still come out correctly.
Right.
So your random test is test number 3. It's step 3 in this process. I'm talking about before that, the basic concept of a single character, like say a white space character, maps to a white space token, or an open brace character maps to a new scope token. Yeah.
So you can picture this like taking a long journey somewhere. You need some fixed anchor points to prove that those random tests are in fact coming out to the correct solution.
Yeah, that's brilliant.
So
so
last week, you remember how we ended it? Sorry, not last week, Wednesday, right? How we ended it was think about all the possible tokens that we could have.
Yep.
These are the token types. I'm saying, hey, there are a fixed number of token types, right? A large subset of those can be expressed with just a single character. So let's get the single character tokens all mapped out. Then we can look at the double character tokens. Then we can start building strings that contain different collections of tokens.
I love that. I agree.
Brilliant. We're on the same page. Let's go. Build it.
You still don't like the Lakehouse, though. It's kind of hurting me a little bit.
I'll come back. As long as you don't screw up any more English, we'll be fine.
All right. Anyways, thank you guys for hopping in today. This was fun. Let's connect on Monday, like Paul would say. And today is Friday, like Paul would say. Is that proper English to you, Paul? Friday? Is that how you say it?
No, I think we can write the test though between sort of now and Monday.
Write code without live stream.
Well, I think what we should do is write them and then review them live stream, because what we're finding is we're not really achieving much on stream, are we? Right. So we should write the code and then say this is what we wrote and why.
So just hear me out. The whole idea on the stream is to allow people to kind of see. I want people to see how we write code. Right, not
badly is the answer to that.
You just hate it so much because we put you in a corner and we kept beating you up. That's what happened. and now you have to see a shrink to kind
yes. You've cost me, right? I'll be sending the bill over. Don't worry.
Don't write code without showing it to people. That's, by the way, any other tutorials on the internet, you will find people literally going in, and what they're basically doing is that they're literally showing you code that they already pre-written. People need to see how we think about this and how we write it in real time. And if we get it wrong, we get it wrong. There's nothing wrong with that. Does that make sense? Yes?
Sure.
Paul, with your You're just scared. Don't worry, Sam. Don't
No,
make
no, no. I was
Paul.
thinking because we know what we're going to write, right? We've done a lot of these sessions already, and we haven't really kind of achieved anything. So I'm trying to sort of speed things along
That's
a little
part
bit.
of the fun. Just chat and write code.
Okay.
Sam, don't let Paul write code. He's gonna be the PM from now onwards.
Get some programming done, you lazy developers.
All right, guys. I'll talk to you later. For people watching us, of course, as usual, I hope you're enjoying our sessions. If you have any comments or questions or concerns, please feel free to reach out to Paul directly about any concerns, because I don't expect the concerns to be about anything Joe, Sam, or I did. It's just pretty much Paul at this point. And as usual, don't forget to like and subscribe. I'll see you in another video.
Or can you share your home address?
Oh, sure. Yeah, no worries. Yeah, I'll post it up on a couple of forums for you later.
I'll talk to you guys later. Take care. Bye.
Bye-bye.